Alrighty. Hello everybody, and welcome to the stream. We are getting started on time tonight, which is awesome. Beatwatcher, hello. How are you tonight? Welcome. So, as you can see, I did get my camera fixed, so that's good. There was some sort of driver issue there. I wound up actually having to reinstall the driver, which was super weird. So I got that fixed. I'm also testing out my green screen behind me, so hopefully this will give you guys a little bit better visibility kind of behind me. It looks like it's maybe not completely covered back there, but that's about as close as I can get it for right now. I'm probably going to have to play with the positioning of that a little bit more to kind of eliminate some of these edges over here on the screen, but it's better than what I had. So let me actually move this up a little bit so you guys can see line numbers and stuff. Okay. The other thing that I fixed was I went ahead and changed out the bot that this channel is using. So I moved away from Streamlabs bot and went with Nightbot. So now the commands should work. So if you type in like Kohi, for example, you should get a link to the website and stuff like that. So I believe you can also do commands. And it'll actually give you a listing of the commands there. So that stuff has been fixed. So we should be in much better shape tonight. Okay, so before I jump into things, I just want to really quickly give some credit to the supporters of the channel. So that begins with our partners, who are the highest tier subscribers on YouTube and Patreon. They are Arslia, Gerbolis Inc., Patrick Coolman, and Wensheng. And I'd also like to thank all of the other supporters listed on the screen. They are the Twitch subscribers, the YouTube members on the other levels, and the Patreon members on the other levels. And in addition, I would also like to thank everybody tuning in to the stream here, as well as if you find me over on YouTube, all the archives are over there, as well as the other stuff that I post on my channel, like the devlogs and stuff like that. So thank you guys all very much for being here. It means a lot to me that you guys show up and follow along. And yeah, so anyway. So last night, we actually made some pretty decent progress with the engine. So we actually had put, we had put in place raycasting with the ability to actually visualize those raycasts. So when we cast a ray and we move the camera, we can actually see where those casts were cast from using our newly created debug shapes. And so tonight we're going to expand on that a little bit, and we're going to go ahead and do a little bit of hit detection. And so the idea is that I should be able to basically cast a ray at, say, this car here. And then once that ray intersects with this bounding box, we also are going to draw like a little cube at the intersection point. And we're also going to go ahead and save off some information as to whether or not we had hits or not, how many hits we had, and I'll jump into that in a second, where the actual hit was in world space, as well as what type of hit it was, and the distance from the camera at the time, or the distance from the origin of the ray. It doesn't necessarily have to be a camera, right? And so when I say we can have multiple hits, the idea with this as well is that if we have a camera angle like this, where we've got our sponza sort of behind us and we click on the car, it should technically hit both, right? Because that line intersects both bounding boxes. So we're going to implement that, and we'll have a list of objects that got hit, so that if we ever want to have that sort of information where we just want to get all the objects in that ray, we can certainly do that. So that is the goal for tonight. All right. So I just have Visual Studio Code here for debugging purposes, but I am going to be sticking with Vim for the foreseeable future, or NeoVim, I should say. All right, so the first thing that we actually have to add is we need to add a little bit of a support function for our Raycast hit hit detection, right? So we already have all the logic and math out for the generating the ray itself. And now we actually need a way to test for that. So what we're going to do is we're going to head over to our geometry 3D. Put my water ball in front of the screen. That's not helpful. And we're going to head to the, we'll do the implementation first, and then we'll write the header. So we're going to need a method that's going to return a Boolean, right? So a B8, and that's just going to tell us whether or not we had a hit, right? That's the simplest way to detect it, right? So we're going to say raycast, and then we'll say oriented extents, right? And the reason it's oriented extents is because our bounding boxes on our meshes and all of our other things are basically just extents, right? We don't actually have a box object. We just have a min and max extents, which is the same thing essentially as a box. And we can derive all of what we need to know from that. So we're going to test extents. We're not going to be testing a box per se, right? So with that, we need extents 3D is the first thing that we're going to be testing against. And then we're going to call that bounding box extents, right? Just to give the idea of what that is. The next thing we're going to do is we're going to take a constant pointer to a mat4 so that we don't, copy all that data. And we're going to call this bounding box model. And that's going to be the orientation of the bounding box, which will also happen to be the orientation of the mesh that we're testing against, or the terrain, or whatever, what have you, right? So we're going to do that. And then the next thing that we're going to do is we're going to take a constant pointer to a ray, right? We're just going to call that R. Again, there's no reason for us to take a copy of this data. We can just take a pointer to it, right? And then the final thing that we're going to do is we are going to have a pointer to a F32. This is a non-const pointer because this is going to be the out distance, right? And that's going to be the distance from the origin of the ray, to wherever we hit, right? And so that is basically how this method is going to work. And all we have to do now is sort of fill in the blanks in between. So I do want to mention that this particular method for intersection is based on the real-time rendering and essential mathematics for games, right? Credit where it's due. I didn't come up with this formula. I mean, obviously, it's kind of a standard thing, right? Like, but I feel it's fair to give credit where it's due. So we're going to track two things. We're going to track first the nearest far intersection, and then we're going to check the farthest near intersection, and that basically is talking about what side of the bounding box we're actually hitting, right? So we're going to comment this pretty heavily just so that you guys can kind of look at this at a later time and kind of understand what's going on. So we're going to say the nearest far intersection. Okay, and this is going to be within the X, Y, and Z plane pairs, right? And so this is going to be a F32. And we're going to say nearest far, nearest fart, that's pretty funny, intersection, right? And we're going to start that off with a minimum value of 0, right? We can't have a negative distance, right? So the way that we're going to check this is with 0. And we'll just basically say if we have a nearest further intersection that is beyond 0, then we just update this value to that, right? Likewise, we're going to have the farthest near intersection, right? And again, this is going to be within the X, Y, and Z plane pairs. right? And this is also going to be an F32, and we're going to say farthest near intersection. And we're going to set this to something stupid like 100,000, right? And this is basically going to work the exact opposite of this top one, right? So anytime that we have a near intersection that is less than 100,000 units, we'll knock that value down. Then every time we get something less than that, we'll just keep knocking that value down, right? So this is sort of the extent of our two types of intersections that we're going to have. So the next thing that we need to do is we need to pick out the world position from the model, matrix, right? And all matrices have, transformation matrices rather, have their position data encoded in them. So we're going to do a vector 3, and this is going to be, we're going to call this, let's call this oriented position world, right? We'll say vec3 create. So X is going to be the BB model data, which is that array of floats that we have within there. And then we're going to take the 12th element, right? Because the 12th element is our X, right? And then we're basically going to repeat these steps. So I'm just going to copy this and paste there and paste there. And we're going to take the 13th and the... Oh, I thought I pasted again. Right. Okay, whatever. BB model data 14. Right? So we have our X, Y, and Z that we could just get out of the matrix like this. We might write a shortcut method for that at some point, but for now, that's how we're going to do it. All right, so the next thing that we need to do is, if you recall the way that we calculate the extents or the bound extents of our objects, they are based on the min and max vertex positions over the entire object before it's actually had any transformation applied to it, right? And so what that means is we actually have to take those bounds and apply a transformation to it, namely the model matrix, to bring that into the same sort of space that we're dealing with for this detection, right? So we already have the world position here. Now we just need to take the extents that we've got and essentially apply those same transformations. So we want to transform the extents. This will orient, scale them to the model matrix, right? So we're going to say bb extents dot min equals mat for mul vector 3, right? So we're just going to multiply these together. So here this wants a copy of the model matrix. So we have to dereference that and say bb model. And then for the vector itself, it's going to be bb extents dot min, right? And so this is going to be the exact same thing for the max. So we'll just say max here and max here, right? And that's all there is to it, right? Whoa, why did it do that? Okay. So that's all there is to it. To just bring those into the same sort of coordinate space that we're dealing with for all the rest of this stuff. So the next thing that we need is we need the distance between the world position and the ray's origin, Okay. So this is going to be vector3. We'll call this, let's call this delta. Namely because we already have out distance here, and that could be confusing. So we'll call this delta. We'll say vector3 sub. So we're going to subtract the oriented position world. And from that, we're going to do our origin. Right? So we're just going to get that distance. And then the next thing we need to do is we need to actually perform the test. So we'll say test for intersection with the other planes perpendicular to each axis. So we're going to basically have a test for the X, Y, and Z axes. Now we don't actually have those axes yet, so we have to get those first. So we're going to say vector3, we're going to say X axis, and we'll do mat4, and we're going to say right, and again we're going to have to dereference BB model, right? Next we're going to do a vector3 Y axis, and we're going to say mat4 up, and dereference BB model, and vec3 Z axis equals mat 4 backward, right? And this is going to be the BB model, right? And so that'll give us our 3 axes that we're looking for. So we're also going to, just for convenience sake, we're going to throw those into an array. So we're going to say vec3 axes, and that's going to be an array of 3. And we're just going to say X axis. Whoops, I used parentheses there instead of brackets. X axis, Y axis, Z axis. Now, contrary to what you might think, the order that we test these things in doesn't really matter. The test is going to be identical for all 3 axes. So the reason that we're doing this is so that we don't have to repeat the same code for each axis. We can actually just loop through them and test them one by one. So we can say for u32i equals 0, I is less than 3, plus I. Right? And so the first thing that we're going to do is we're going to take 2 dot products. So we need, the first one is going to be F32, and we'll just call this E for vector3 dot, equals vec3 dot. There we go. And we're going to take the dot product of the axis sub I, and we are going to take the delta, right? So we're basically going to get the dot product between those two, or the difference between the angles, right? And we're also going to get the difference between the angles for vec3 dot the ray direction and the axis, right? So axis sub I. Okay. So those 2 things will give us some information that we need to know for the individual test, right? So the first thing that we want to do is we want to check to see if the absolute value of the F dot product that we have is greater than 0.001 F, right? So we want to basically make sure that it's like not 0, essentially. We want to make sure that it's a positive number, of course, and then we want to make sure that it's just above 0. So that's sort of our tolerance, right? Anything below that is going to be kind of considered coplanar, is going to be kind of considered a miss, right? So the next thing we're going to do is we're going to store distances between the ray origin and the ray plane intersections, right? And variables that we're going to call T1 and T2, right? So the first thing we're going to check is intersection with the, we're going to call this the left plane, right? Because there's going to be one to the left, one to the right for each axis. So we're kind of just rotating around in space or rotating up or what have you, right? So there's going to be something to the left and something to the right that we're going to be testing. So the first thing we're going to do is test against the left plane. So that's going to be our T1. So we're going to say F32 T1 equals E plus BB extents min elements, and we're also going to say I. And then we're going to divide that by F. So essentially what we're doing here is, this is where our loop kind of comes in handy, right? Because we can reference the ax, or the axis by sub I, but we also, since we're doing a test here, we also need to know the bounding box min on that same axis. So if we didn't do it this way, we basically have to write this same code 3 times, and that's kind of dumb, right? So intersection with the right plane. And this is going to be F32 T2 equals, and this one is going to be E plus BB extents max. Whoops. What did you do here? Okay. That should be equals. Apparently I suck at typing tonight. Let's delete there to the end of the line and try this again. So we're going to say BB extents max elements sub I divided by F. Okay? Stretch redeem for 250. Thank you for the stretch redeem. I appreciate that. Should probably go ahead and hydrate too. Okay. So, basically what we want to do is we want to ensure that no matter what, that our T1 represents the sort of nearest intersection. So we're going to do a quick check to ensure that T1 is the nearest intersection, and swap if need be. So we're going to say if T1 is greater than T2, then we're basically just going to do a simple swap. So we'll say F32 temp equals T1. Then we'll say T1 equals T2. And then T2 equals temp. Okay? So that is that. And then basically what we're going to do is that check that I was talking about earlier, where we're going to say if T2 is less than farthest near intersection, then farthest near intersection equals T2. And then if T1 is greater than nearest far intersection, then nearest far intersection equals T1, right? So this is taking those values up here that we started with and sort of just bringing them in a little bit. All right, now, at this point, we can say if the far is closer than the near at this point, then we can say that there is no intersection, right? So, oops. So the test for that would be if farthest near intersection is less than nearest far intersection, then we can just boot out right here and say return false, right? And that means we're done, right? Otherwise, we have another case that we need to handle where, let's say if we fall into this range here, where we're below this 0.001 and, you know, but above 0, right? Or anything less than that, really. So we're going to handle that case. And this is a bit of an edge case, right? Where the ray is almost parallel. Colorful, thank you so much for the follow. I appreciate that. Welcome. So if the ray is almost parallel to the planes, then they don't have any intersection, right? So we're going to do a quick test on that to see exactly how close they are. So to do that, we're going to say if negative e plus bb extents dot min dot elements sub I is greater than 0.0f, or let me see, I should probably, yeah, no, that should be fine. Okay, if negative e plus bb extents max elements sub I is less than 0.0f, right? So if either of those cases are true, then we're going to say we don't have an intersection. So we're going to return false, right? The last thing that I want to do is all the way down here at the bottom, we want to do one last final check. So we're going to say if the nearest far intersection is exactly equal to 0, we're going to return false. So what this would mean, the only way that we would actually get here is if we did a raycast from inside of an object. And that would basically say that the collision happens at the camera. In our case, I don't think we really want that. So, in fact, let me notate that here. Basically, prevents intersections from within a bounding box if the ray originates there, right? So we're basically just going to block that case from happening. Otherwise, if we passed all of these tests for all the axes, then that actually means that we have a intersection. So we can set out distance to the nearest far intersection, right? And then return true. And that is the function. So if you're more interested in a deep dive into some of the more complexities of this math, I would say definitely check out this, right? Because it could probably do a way better explanation than I could, quite frankly. But yeah, this is how we're going to calculate our intersections of rays and oriented bounds. Okay. So, the next thing that we're going to do is, well, we need to add this to the header file. So let's go ahead and do that. Geometry 3D header file. Where did we put that? Did we put that? I guess it doesn't matter. I'm going to put that here. So there we go. Let me go back. Yeah, I put this towards the... you know what? I should probably put this at the bottom. Let's move this. Let's move this down here. And let's actually do the same thing here. Okay. So that'll give us what we need to actually perform our checks, right? So the next thing that we need to do is we probably ought to go to our simple scene and fill out this, right? Because this is sort of the next step to this. So we're going to iterate the meshes in the scene. We'll say U32 mesh count equals darray length, and we'll say scene meshes. For U32 I equals 0, I is less than mesh count plus I. Basically what we're going to do at this point is perform the test that we just wrote on each one of the meshes. So we're going to say if, and then raycast oriented extents. The BB extents is going to be the, you know what, let me get a convenience pointer so I don't have to type scene meshes sub I every single time. So mesh pointer M equals scene, the address of rather, scene meshes sub I, right? And now here I can say M extents, right? For BB extents. Next we need the model matrix, so we can pass M. I think we're actually going to have to get that. Yes, we are. Okay. So we'll have to say mat for model equals transform world get, and to that we're going to pass M, the address of M transform, right? And then here we can pass the address of model. The ray should just be R, just pass through as it is. It's already a pointer, so we should be good there. And then distance, we'll need to save that, so we'll say F32 dist, and we will pass the address of that here. So if we hit here, that means if we get to this block of code, that means we have a hit. And so that means we actually need to go ahead and set up our raycast result, right? So the first thing that we'll do is say if out result dot hits does not exist. So actually we'll do this. Then we're going to go ahead and say darray create, and then out result, whoops, not out result, raycast hit is the type there, right? So we should be setting out result hits to that, right? So we'll create a darray for that. And then from there, let me see. Beat Watcher, interesting stream, but unfortunately I have to go. It's almost 4 a.m. in the EU. Oof, ouch. I'm going to watch the VOD later. Okay, good night. Thank you for popping in. Appreciate it. Have a good one. Okay, so we're going to go ahead and create that array. And then here we'll say darray push. And we want out result hits. And we need some value which we haven't created yet. So now we'll create the hit information. So we'll say raycast hit, and we'll just call this hit. And we'll zero this out just to be safe. We'll say hit dot distance equals dist. Hit dot type equals hit type oriented bounding box. Hit dot position. So this is going to be involve a little bit of calculation, but not too big of a deal. So we're going to say vec3 add, And this is going to be the ray origin, right? And then it's going to be another calculated vector. So we're going to say vec3 multiply scalar. And we're going to take the ray dot direction and multiply that by the distance, right? So we'll say hit dot dist, right? And that will actually give us the position of where the collision actually happened. And then finally, hit dot unique ID is equal to m dot unique ID, right? So we have some way of knowing what we actually hit. And then as far as this push, we just push the hit to the array, and we're good to go. And I think that's actually all we need to do. Yep, that should be it. So we basically just iterate all the meshes in the scene, and then perform this. Now, you might be thinking, maybe not, but if you are, rightfully so, this needs to be optimized. We need some sort of spatial partitioning to speed this up. Otherwise, a scene with thousands of objects will be super slow. And I'm going to move this to this line, and we are iterating the meshes in the scene, so that's fine. We can add terrain and stuff to this later, but for right now, I'm just going to focus on meshes, okay? So what I mean by spatial partitioning is something like an octree or something like that, that splits up the scene. So we can basically just check the objects in a specific portion of the scene that the ray is actually in and actually going through. Because, if there's something that's way off to the left, 1,000 units off to the left, we don't need to be testing that stuff, right? If it's not in the direction that the ray is headed and it's not even close to the ray, why are we going to test it, right? So we just need to eventually come back and optimize that, right? And that's something we need to add anyway for other purposes. But this is one of those things, right? So we're just going to put that in there as a to-do. Okay, so I think that's all we need to do for our simple scene raycast. So now back over in our testbed main, we need to do some work over here to actually handle that. So we were calling this method already, which of course was always returning false. We missed one thing. We are still returning false over here. So we actually need to say, we need to return at result hits is not equal to 0. Right? So if that array exists, then we know we have hits and we can return true. Otherwise, it'll return false, right? So what we can do is, instead of having this hit variable and stuff like that, I'm actually going to move this there. And get rid of it, right? And so if we actually have hit, then we're going to come in here anyways, right? Just simplify this a little bit. So what we're going to do now is we're going to iterate through our hit list, right? So actually we need to get a count on that first. So we'll say U32 hit count equals darray length. I'm going to say our result hits. And then we'll say for U32, I don't think we're doing any other loops here, right? Yeah. U32I equals 0. I is less than hit count plus I. And now we can basically just loop through each individual hit that we have. So the first thing we'll do, I guess, let's go ahead and just grab a pointer to that. So we'll say raycast hit, and we'll call this hit. And we'll say r result dot hits sub I. And the first thing we're going to want to do is obviously create a debug line. So I'm actually just going to copy this code here. I'm going to copy this and put it here. But we're going to say yellow for hits, right? So we'll just change this to RG, and then the B is going to be 0. Right, so that'll change that to yellow. And then instead of creating it from the origin off in some direction 100 units, we're actually going to create it until the location of the actual hit. So we can delete all of this stuff. To about here, right? Yeah. So I think the next thing that wants is the location. So that's going to be hit position. Is going to be our second thing there, right? And we're not going to have a parent transform, and it's still going to be the test line. Let's see, initializing. Oh, I forgot to take the address of this. Okay, so this is starts and ends at the intersection. Okay, so that's that, but we also want to add one more thing. We want to create a debug box to show the intersection point. So we'll do a debug box 3D. And we'll call this test box. Debug box 3D create. So the size of this, we're just going to, we'll go ahead and create a vector 3. Oops. And we're just going to set this to, I don't know, 0.1 units. 0.1 F, right? The transform parent, in this case, is also going to be nothing. And then this is going to be the address of test box. Right. We need to do debug box 3D initialize. So that's going to be the address of test box. Debug box 3D load address of test box. And then we need to do debug box 3D. Let's see. Oh, you know what? We are actually going to have to set a transform for it, I think. Yeah, we are, because we don't actually have a way. I mean, we could set extents, I guess, but that kind of sucks. Let's set the color real quick while we're here. So we'll set the address of test box and the color. Actually, you know what? We're gonna leave the color default white. That should stick out enough, actually. So let's go ahead and create a let's see, do I want to set a... I could have swore that I had a way to set the position on this. I guess I didn't, though. All we can do is parent set. I guess we could just do extend set. I guess we'll just do it that way. It's fine. All right, so we'll just calculate some extents for it. So extents 3D ext ext.min equals vec 3 create, and then we'll just say hit.position.x minus 0.05 f. We'll say hit.position.y minus 0.05 f and hit.position.z minus 0.05 f. And then we can take this line, duplicate it, set the max. And then these just need to turn into pluses. And then debug box 3D extents set address of test box, and then the extents, right? And then finally darray push, and then that's going to be state test boxes, and the value that we're going to push is going to be test box. Okay, so I think that's everything that we need to do. I am going to move this hit down into this this loop, because we can say, let's say ID and distance, right? And so we can say, let me move this one more line down. So we can say hit unique ID, hit distance, just to give us a little bit of context, right? Let's go ahead and try and build this, see if I missed anything. I did. Line 110 does not return a value in all control paths. Oh, am I nested in one level? I am. Which means, oh, all of this stuff is wrong. Wait. Yeah. So basically all of this should actually be here. Did I write that? Okay. So let's go ahead and swap over to our VS Code and run this and see what we get. So we'll load up, and we'll just take a quick look at our car here. And it looks like we got a hit. It looks like our box did not do what we expected it to do, though. So It looks to me like the line ended in the right spot, but where is the box? The box is not there. Oh, you know what? How much you want to bet we're not actually rendering it? I don't know if I plugged that in last night or not. I think I did this as a hack, so let me search for hack. Yeah, okay. Whoopsie. One last step. So we need to do the boxes. Right. This is going to be box count. This is going to be test boxes. Test boxes. We don't need a UID, unique ID for the box itself. We want to push that into debug geometries and debug geometry count ++. I think. I think that's all we need to do. Okay, let's build again. And we'll go ahead and run. And load up. And try this again. And oh, we have a box. So we just weren't drawing it before, right? It's being generated, but we just weren't drawing it. So we can just kind of keep clicking here and seeing all of our collisions happening all along this box, right? And we can see how they all sort of originate from the same space there, right? And one other thing that I've sort of accidentally, but not so accidentally did, was I made sure that some of these raycasts went through this car to hit this building back here, right? And you'll notice it's actually hitting the bounding box, not the actual visual mesh itself. That would be a separate test. But we can see here that it actually does go through meshes like that. So if I kind of position this where the car is behind it and I click where I think the car is going to be, it's going to hit both of those things, right? So that works. The other thing is our logs seem to be working as well. So let me see. I'll do a no hit here, and then I will move the camera. And I will click once so that it goes and hits both objects. And we see we get 2 hits here, one for ID 11 and one for ID 12 with different distances. So those are working as expected, which is awesome. And of course, if we have misses, those come off as magenta lines. So we can very easily track those things. And so this provides us a lot of good visual feedback for debugging and stuff like that. So we're going to be using these things a lot, as you might imagine. All right. So there is a problem with this that I can actually think of, and that is going to be if I unload this, it's going to poop itself. And that is because it is requiring things that no longer exist to be in place, specifically a D-array, right? And so we actually need to fix that, right? Now, if we go in here and we haven't loaded a scene, we click, it's not going to do anything, right? But if we load a scene and then try and unload a scene, it is going to crash. And I suspect the reason for that is because we actually need to clean up our debug geometries, right? Because it's trying to do this stuff here when it really shouldn't be, right? If we unload the scene, we should probably be getting rid of these test lines and whatnot as well. So I could very easily also wrap it in this test, which might solve the problem. In fact, let's test that theory real quick. So I'll put this here. And then there. And then I should probably also check state main scene. Actually, is that a pointer? I don't remember. I don't think it is, actually. Okay. So I don't need to do that. All right. So we can just check this. Let's see if that fixes the bug. It's going to kind of fix it, but not really, right? So we'll load up a scene, do a couple of raycasts, right? Cool, whatever. Unload the scene. Okay, well, it's not trying to draw those things, which is good. But if I load the scene back, we'll see that they're still there, which doesn't really make any sense when you stop and think about it, right? Because these would technically be from our last scene. Like, if we were actually going to change scenes, we would want to clear this out. So, well, let's go ahead and do that. I'm going to go, I think, to the top here of our testbed main. And where do I want to put this? Probably before the boot and all of that. I'll put it right here. All right, we're going to make a static function. It's going to return type void, and we'll call this clear debug objects. Right? Void. All right. And all we're going to do is, first off, we need the state. So we should actually have a cold cast for that here somewhere, I thought. Yeah, here we go. So we'll paste this here. This also, actually, I need game inst. So we actually have to take this in as well, which is no big deal, because we'll have that anyway. So do that. So that way we can get that, the state, and then we'll say if state, we'll do test boxes first. Then U32 box count equals darray length, state test boxes for U32 I equals 0, I is less than box count plus I. And then we'll just go ahead and proceed through these and unload them, right? So we'll say test box, rather debug box 3D. Just call this box equals the address of state test boxes sub I. And then we'll say debug box 3D unload, and then we'll pass box, and then debug box 3D destroy. Debug box 3D destroy. There it is. Okay, and we'll pass box. And then once we've gotten to the end of that array, we'll say darray clear state test boxes. Right? And so that's going to be the proper way to clean that up so that we free all of those resources as well. So as you might guess, we are going to grab all of this and do the same thing for lines. Line counts. Test lines. I love the name. Holy sheet. Thank you so much for the follow. I appreciate that. Okay, so we need test lines. This needs to be debug line 3D. And rename this to line And oops. Line 3D unload. Line 3D destroy, and then we will clear the test lines. All right. So now we have some way to sort of clean up all of our debug objects when we unload a scene or when we do some other stuff that we should probably do that as well. So there's going to be a couple places we're probably going to want to call this in. One of those is going to be unloading scene, right? So after we call simple scene unload, basically anywhere we call simple scene unload, we're going to want to say clear debug objects, game inst. So grab that line. Let's see. So here we're doing an unload as well. So we'll paste one here. Oh, this is declared above. All right, we'll come back to that. I think, though, that might actually be the only places we need to do this. Okay, so let's actually move this. I could forward declare it, but heck with it. Let's put it right there. Okay. Let's build and run. And one way I suppose we could test this would be, we'll keep an eye on our logs here. And I will press M to spit out our memory amount, right? And we'll go ahead and take a look at this. So we have 276 megs taken. GPU is about 1.06 gigs, right? And that's just because of all of the buffers that we've sort of pre-allocated, right? So we'll go ahead and load. Right? And then we'll create a whole bunch of these things, right? We'll just, I mean, these don't take very much memory apiece, so we'll just do a whole bunch of them. Right? And then unload and hit memory again, and we should be basically back to the same point. The only reason that this memory is increasing is because of our logs here, right? So remember, we do have a whole log here that's continuously increasing. So that does take memory as well. But yeah, I think we are good to go. It doesn't look like we're leaking any memory either. No. So incidentally, if this said more than 0 this frame, that would mean we're leaking memory. So this is the total number of allocations that we've made in total, and it does not count freeze, right? This right here counts basically the allocations versus the freeze. So if that number is 0, then that means we haven't leaked any memory. So we're good to go. All right. So I guess the next thing that we need to do or start on is probably our detection for the gizmo, is what I'm thinking. We're actually, I suppose we could either do the gizmo or we could do object selection next. Object selection is kind of just a stateful thing. I guess we could do object selection. That we could probably get done in tonight. Because we have a lot of stuff that we actually have to do for our gizmo to actually get that functional. So let's do this. I haven't done this in a while. Use the console to exit. We should be good still. Okay. All right. So as far as the raycast feature is concerned, I'm going to consider this done, actually. So let's do a get status. So these are new things, git diff. Just review this real quick. So we added this function. So that all makes sense. There's the header file. And then we just added this into our simple scene to actually utilize that new function. Again, we could add this for other types as well, but for right now, I think mesh is sufficient because we want to actually do a little bit of work around our terrain and stuff before we actually mess around with that too much more. And there's our clear debug objects. Here's our hit response code that generates our debug objects. And yeah, okay, I think we're good. I do want to point out also, for those of you watching, this is an interactive stream. So if you guys have any questions about anything, feel free to jump into chat and ask, and I'll answer it to the best of my ability. So, I'm going to add these gets commits, added oriented bounding box, raycast hit detection, hooked up debug displays for that. All right, so we've pushed that there. Let's go ahead and make a pull request real quick on that. All right, let's get that into the main branch. So that way you guys will all have access to that. Oh, why am I not logged in? Really? GitHub, why have you done this? Okay. So, we'll go ahead and create our pull request into main. So this is the diff that we kind of looked at before, but this is also for the entire branch, right? So this has got all of our changes so far. So I'm going to create this. And merge it. And delete the branch. So that is another thing. We can actually go into our roadmap and update that real quick. I need to get in the habit of actually doing this when we complete features. So I know that was in here somewhere. Object picking. Well, all right. I can't call object picking done yet because that's not technically done. Everything that we need to do it is done, but the object picking itself isn't done. But raycasting is done. So we can move that to down here. Was there anything else we knocked out in the meantime? I don't think so. Gizmos we're kind of doing now. Profiling, this is another one we're going to need to hit sometime soon. All right, so let me save that. So for those of you who don't know, by the way, I do have a website for this, which is kohiengine.com. And this gives you links to everything about the project. So I do have links to YouTube, the Twitch channel, the GitHub, the Discord server that we have, as well as Patreon if you want to support me there, as well as, sort of the newest stuff that we have here. So you guys can always find the newest, latest, greatest on the project here. And then if we go to GitHub, it'll take you right to the project. And if we go to Wiki and scroll down to the bottom, we have a roadmap here. And this is what I was just looking at. So this is sort of the feature list that I have in mind immediately of things I want to do. It is not an exhaustive list. There's going to be stuff that gets added to this as we go. But it is the list I'm sort of working off of right now. And so, as you can see here, we have quite a lot to do, but we also have quite a lot that we've done. So this is all the stuff that we've implemented so far, right? So there's quite a lot in there. UI is sort of separated out into its own section because it's going to be a big thing. This is going to be the UI that powers the editor. So we're going to be starting on that very soon. We have some renderer stuff in here too. A lot of this is pretty high level stuff. DirectX, OpenGL, Metal backend support is going to be a thing. Speaking of that, and that might be something we tackle, if not tonight, very soon. I foobarred a little bit. So, Macs do not support Vulkan natively. They use a toolkit that is called Molten VK, which is a translation layer, basically. And it translates all the Vulkan calls into Metal calls. And it's a fantastic framework, and it's allowing us to actually be able to port Kohi and run it on Mac without having to write a Metal layer, which I want to do eventually anyways for reasons I'll explain in a second. So while that's really great, obviously having to go through any sort of translation layer is never an ideal thing, right? You don't really want to ship with that because it's not going to be ideal for performance because it's another layer of code that you have to go through. And it's making all sorts of translations and having to run through extra layers of logic, and that's just generally not a good thing. And one of the limitations is when we say that we're dealing with, or that we're working with a Vulkan 1.3, that is not necessarily the case when we're talking Molten VK. Molten VK right now for M1 Max only supports up to version 1.2, but like 205 or something like that. And the people that are working on that are obviously doing an awesome job. And it's it's an open source thing, and it's great, right? But as I mentioned, it only supports 1.2. And the changes that we made recently to the back end required us to actually step that up. Stretch redeem. Okay, I can do that. And thank you for the follow. I appreciate that, Nicholas. Thank you very much. So one of the things that we did to support the ability to switch topology types with our shaders is that we are relying on a feature that is only available in 1.3. And I didn't realize this until I actually went to go ahead and... whoa. That was a lot of follows all at once. What happened? Hello. First time chat. Hello, I'm from Germany. Nice to meet you. Hello. Welcome to the stream. I just got a whole bunch of follows showing up in my... Did we get raided or something? I don't see a raid on here. I wonder if it's legit. Yeah, me too. Looking at the names, I'm not sure. Because I'm only seeing 14 viewers. Yeah, it looks like bots. Someone's trying to screw me up. Whatever. Yeah, I think it's bots. Some of them look real. Some of the names look real, but there's some of them that are auto-generated. Yeah, I can't stand bots either. That's kind of annoying. All right, well, I guess that's just going to keep notifying for a minute. I don't know if there's a way to actually stop it or not. Let me see if I can just turn off alerts, and maybe that'll kill it. Nope, apparently not. All right, well, I'm not going to worry about it. Can use this tool to remove all the bots. What tool? I'm really not sure what people gain by, like, creating a whole bunch of bot accounts and following people. I don't really understand what the point of that is, to be completely honest. I'll have to look that up. I thought Twitch had taken care of, like, the bot problems a while ago, but apparently not. All right. Well, I think I'm just going to turn alerts off entirely for a bit. That way we can actually continue to stream. Maybe it makes the accounts look real so they can be used as view bots. I'm not sure. Yeah, that's very strange. Yeah, I'm not sure. Okay. Anyway, as I was saying, basically what I did was I bumped up the version to 1.3, which is going to wind up being an issue because now it's not going to run on Mac until I actually fix this problem. The issue with this is it requires an extension to actually be able to run on 1.2. So let me see, right in here somewhere. Yeah, so see, we stepped this up to 1.3. What is going on with my Vim now? Okay, apparently my Vim is just freaking out as well. Oh, there it goes. Okay. So, there we go. So, basically, we're sitting on 1.3 right now, and I'm going to have to step this back to 1.2, or maybe dynamically handle both situations. But to do that, I'm going to have to load an extension. So, I don't know if I really want to do that tonight or not, but technically the Mac builds are broken until I fix that. So that's kind of a big deal. So maybe I will try to fix it tonight. And I'll show you what I mean. So I'll bet if I change this back to 2. And, whoops. And oh, you know what? Hold on. Before I do that. You know what? I'm just going to quit Vim altogether. Because it's doing some really weird stuff. I'm just going to relaunch it. Alright. Or maybe it's, I don't know, maybe it's input, maybe it's user error. I'm not sure. Alright, so I'm going to open up the backend. Search for version. Right, so, oh, I thought I did away with this. All right, whatever. Let me go to git checkout main. And we'll pull that down, right? Because we did the merge request, or the pull request, rather. So if I switch this back to 1.2, and build. And run. We're going to get some nastiness, right? All of this stuff, in fact. So it's basically bleating about the fact that we're trying to use something that isn't supported. And this is what you get if you actually try and run it on Mac right now, which is obviously not great. And it all has to do with our ability to use this guy and our dynamic state. So I'm kind of thinking that maybe we should just try and spend a little time and see if we can actually figure this out. So what I'm going to do is I'm going to start by taking a look at this guy. So see, this is provided by version 1.3, right? Which is this guy. Or the equivalent command, which is this guy. But I'm pretty sure since this is provided by an extension, I'm thinking that I'm going to have to manually load this. So let's see. It's command buffer, primitive topology to use for drawing. Do we have to use a different type for that? This is only giving me information about the 1.3 version. Extended dynamic state is what it was talking about, right? Yeah. So let's take a look. Maybe this will give me a little bit more information. Extension and version dependencies. Okay, so this either requires this or version 1.1. So if we're on 1.2, we should be good. New commands. So here it is right here. Set VK command, set primitive topology extension. Extending VK physical device features 2 and VK device create info. We have a new structure here. So we'll have to fill this guy out, obviously create his type. And this is a bool, so I guess we'll have to set this to true as part of the create info. And then it looks like extending VK dynamic state, we'll have to use this instead of just this portion. We'll have to actually use the extension. VK structure type. Okay, that's that. Permission to 1.3. Okay, I know about that. So I guess let's take a crack at this real quick and see if we can actually get this, if we can get this to work. So I'm going to move this off screen, and I'm just going to sort of reference it from time to time. So the first thing that this said was it extends. Let's see, where was that? I think it said it extended the create info. Was it device create info? Let me bring this back down here so you guys can see it. VK dynamic state. I guess I got rid of the page somehow. So I need that. We don't need vertex input dynamic state, I don't think. Maybe we do. No, I don't need that. Okay. So if all we have to do is set the S type when we go to use this structure. Okay, so if it's included in the pnext chain of the physical device features 2 structure passed to get physical device features 2, it is filled in to indicate whether each corresponding feature is supported. We should probably check for that. I might skip that at first. Blah, blah, blah. This whole huge thing can be used in the pnext chain of device create info. So this is a device extension then. Okay. So I think what I'm going to do is go over to device, because I'm thinking that's where most of this is going to wind up taking place. Device features, I could add it here, but I think the device create info is where I'm going to want to actually add this. So device create info dot pnext, right? We'll have to set to something. Let me insert that for the moment and get this structure. So that's going to be this guy. We'll go ahead and set this up here, I guess. So I guess we'll call this extended dynamic state. And then equals. We had the S type here. Right. And then we should be able to just say extended dynamic state dot extended dynamic state equals VK true. And then we should be able to set this to the address of extended dynamic state. So that's that. We do need to actually load this extension. Extension names is here. So what we're doing here is, you know what, I'm going to get rid of this second window. We don't need it right now. What we're doing here is we're using the KHR swap chain extension name and potentially the portability subset if portability is required. So I think what I'm going to do, and this is kind of a hack, but I'm going to just jam this into this array in both cases. Nope, that's not the one I wanted. Okay. Right. So now I should be able to take this. Add that there, and then this will be 3, this will be 2, this will be 2, this will be 3. And that should give us what we need there. So we should be able to load that. And then the only other thing I think I'm going to have to do is I think I'm going to have to load that function dynamically, but let me try building this first. And running. Sabab, hello, welcome. First time chat, welcome to the stream. Oh, illegal instruction, that's pretty neat. Okay, what did we do? All right. Oh, that's an assertion failure. Okay. Device extension not supported by selected physical device or enabled layers. Really? Oh, it's misspelled. It's missing the E at the end. Whoopsie. I should probably be using the enumeration for that. In fact, I think there probably is one. Let's see. VK ext extended. Okay, am I going to have to type it out this way? VK ext extended dynamic state extension name. Three? What is this? VK extended dynamic state 3. Okay, apparently version 3 is what we're going to go with. Sure. That works. That seems a little safer anyways. Alright, let's try this again. Still not convinced it's going to work. Okay, so we got much further that time. I don't see any sort of device created successfully with that. So that means we probably did the thing correctly. VK set, command set primitive topology. Segmentation fault. If I had to guess, that is probably because we're not using the extension version of that. So, that was supposed to be this guy. And that was under Vulkan backend. So, line number was that? 2123. All right, so let's actually just try. Oops, that's not what I wanted to do. Let's try adding this in here like this. Command buffer handle s current topology. And we'll comment this guy out. And we'll see if that just works by itself. Let's see. Undefined symbol. Right. So that means I do have to load it manually. Great. Okay. So let's go back to Vulkan context. And I'm going to add a function pointer here. Because the pattern for this before has always been there's like a pfn underscore and then the function name. That's always kind of been the thing, right? And then I'll insert the actual function name here. And then we'll just fill this in from the device. So device, let's see, after we've created the device is probably the time to do that. So after we do that, we'll do it right here. Let me see if I can remember how to do this. So context, vk set primitive topology ext equals, I think we have to cast it, cold cast it to that type. So pfn, and then I want to say vk device. What was that? VK get device. Device proc. Oh, what was it? could have swore that there was a vk get device proc address. There it is. Okay, so we need the context device, logical device, I'm thinking. And then the p name is going to basically be that again. I think that's right. Oh, you know what? We're not actually using this yet, so we need to point that to context. All right, so that was in... we need to say context dot that. I think. So we'll build and we'll run. Segmentation fault still. Ooh, it's null. So does that mean that we did not retrieve the thing? Let's put a breakpoint here and restart. So yeah, sure enough, it didn't do it. I think it's supposed to be device because it's device specific. I don't think it's supposed to be instance. VK device, yep. That is the logical device. All right, let's look at the handy dandy spec again. Because I don't think in order to support systems with multiple Vulkan implementations, function pointers returned by this may point to dispatch code. Calls for different implementation. Blah, blah, blah. Okay. Return is of this must be cast to the type of command being queried before use, which is what we did. The function pointer must only be called with a dispatchable object, the first parameter, that is device or child of the device. So we've done that. Behavior. So device is okay. So we don't have an invalid device. We don't have a null device. We have a valid device. We don't have a null string. So requested core version device level dispatchable command. Enabled extension device level dispatchable command. So we should have this. M. Fatah, hey, I've been following your development since the very beginning. Very good progress so far. Cool, that's awesome. Glad to hear it. Thank you for following along, first off. I really appreciate that. It's always cool to hear from folks that were there sort of at the beginning. So, welcome to the stream, by the way. I'm just trying to sort out some issues right now with Vulkan versions, because I did a whoops and used a feature from 1.3 that isn't supported on 1.2, which breaks Mac compatibility. So I'm trying to get the extension to work so it'll run on Mac. Okay. Yeah, so as far as I know, this should be good old Stack Overflow, which is probably not going to be correct, but get instance proc address is to get the function pointer that will always work with any device created from the instance passed in. However, the functions returned may include dispatch logic, typically to account for extensions that may or may not be enabled for the device that may slow down the call. This is why proc address exists, to get the function that doesn't have dispatch logic. Okay, that makes sense. You're not obligated to use them, but it may help get some extra speed. So I wonder if I should just use get instance proc address, if that's going to work. Yeah, this is exactly what we've done here. Yeah, so I don't see why it should be returning null. Maybe it doesn't need the ext. Nope, still null. I wonder if I do instance proc address and just use instance here. Oh, we did get something. So that's interesting. The device version of it didn't work, but the instance version does. But it still crashes. Segmentation faults. Is there anything in the logs? I don't think so. So I wonder if there's something else that I haven't done. Let me look at device and then what was it saying that I could do with querying to see if that was supported? BK physical device features 2. Okay, so maybe I actually have to... Maybe I have to do that first. Let's see. Wait a minute, when we're... So I'm actually wondering if we have to query for that property first before it'll like actually tell us whether or not it's, before it'll actually work rather. Swap chain support, depth format, I don't need that. Select physical device, this is probably where I need to look. Let me look. Features 2. And then VK get physical device features 2. Physical devices sub I. And address of features 2. And I'm going to go to device. And I'm going to debug this and see what it gives me. Interesting. It didn't like that. Oh, I have to fill out the S type? Really? On something that I'm querying? That's kind of... All right, let's try that again. Worked that time. All right. Features. Oh, I think it said it extends this, doesn't it? Yeah, it's not in here. So if I do... if I do... Where was that? This guy. Ah. Dynamic state next. And then this is going to be equal to VK physical device extended dynamic state features extension. Oh, it needs to be S type. This is the most ridiculous S type I've seen so far. VK structure type physical device extended dynamic state features 2. I don't think I need 2. I think I just need 1. I think. Oh, I forgot to assign it. And then I can say features 2, p next is the address of dynamic state next. This is one of those things I really don't like about the Vulkan API. Oh, what is with my typing tonight? Should be that. So let's go to here. Oops. So in this dynamic state, extended dynamic state 1. So it is supported. I wonder if it'll use it now that I've done this. Okay, it did get a function pointer to it. Well, this is annoying because this isn't giving me any information on why it's actually segfaulting. As far as I see here, I have a valid function pointer. And all of this is valid. Oh, wait a minute. Wait a minute. That might not be true. Oh, I'll bet the current topology is wrong. I'll bet it's using a value that doesn't exist. Let's see. What does this actually expect? VK primitive topology. So primitive topology, topo. If I'm just going to do a hack here real quick. S current topology equals VK primitive topology line list. S current topo equals VK primitive topology line. Yeah, see, there's no, it's not that. Because there's no extension types. I was just wondering if it was maybe that, but it's not. This is one of those things that's pretty frustrating about the Vulkan API is not only the super long structure names, but sometimes you just run into stuff like this where it just segfaults and you have no idea why. So with all these other things, I think all we do is examine the features, requirements, and queue info to see if it actually meets what we expect. I don't think there's anything that actually enables anything else. So this is just all about queues, surfaces, swap chain support, device extensions. So this is just checking that our required extensions exist. Yeah, all it's doing is checking. It's not actually assigning anything. So, yeah, that's interesting. I'm not really sure where to move on from this one. I mean, obviously this should work, right? We are told that it's supported. Device create info. So we've done. I wonder if it has to do with this 3. Yeah, see, it's still saying it's supported. We still get a function pointer. Wait a minute. It worked. Okay, I think the only thing worse than not understanding why something is not working is not understanding why it works. Okay, so does like all of our features still work? Okay. So the only thing I can think of then, the only thing that I can think of is that we were just loading the wrong extension and using the wrong version of that. It's the only thing I can think of. It's got to be that. But this should actually work. So let me just do a diff real quick. So we've switched back to 1.2. It's not that much code, actually. So, all right, so what I'm going to do, git checkout. I'm going to call this bug fix. 1 to topology. Reverted back to Vulkan 1.2 to restore Mac support. Had to load extensions to support topology dynamic state. Origin bug fix 1 to topology. What I'm going to do is I'm going to test this real fast on the Mac and see if it actually works. Which I don't know if I actually have a way to show that to you guys or not. I can try and figure that out real fast. If you give me a second, I just need to hook something up. I don't know how this is actually going to work, but I think I can actually pipe this through so that you guys can see it. I think, though, I might actually have to sacrifice the camera to make that happen. Let me see. Let me see if this works. No signal. Give me 1 second here. And if this doesn't work in like a couple seconds, I'm just going to give up, but I've got a switch here that I'm hoping will do it. Yeah, I'm not thinking it's going to work. All right. All right. We will, I'll have to figure out how to make that work. I think it's something with the max video output is just not. Oh, let me actually try. Maybe it was just asleep. See if I can get it to come through. Okay, I think. Did it get it? Oh, it's not going to do it, is it? Did it for like half a second. Okay. Some weird Apple thing that they're doing. All right, I guess I can't do it then. All right, was worth a shot. I'll see if I can figure out workaround on that for the next stream. But what I can do is just sort of pull it here on this machine and show you guys on the camera so that we can see it running, because I'm not streaming from this machine. So let me just pull real quick. All right. And clean and rebuild. And hopefully we will be good to go. Nope, so the Mac still doesn't like that for some reason. I'm not 100% sure why. So I'm going to have to do a little bit more troubleshooting on that. I'm not going to merge this into main. But I will do a little bit more troubleshooting on that and see where I can get with it. Because I'm not sure. I did revert it back to 1.2, which this should support, but maybe I'm using still something that's a little bit too new for it. So as far as the Mac support goes, I'll have to come back to that later. But we're like 90% of the way there, I think. So I will be fixing that or I'll have it fixed probably by the next stream, and I'll just go over what the fix is. So with all that said, I think that's going to do it for the stream tonight. We did accomplish what I set out to do tonight, which was to get our ray collisions working. So that is awesome. If you guys have been just watching and you haven't followed yet, I would ask that you please follow, just so that you can see my notifications next time I go live. If you haven't already, go ahead and check out my YouTube channel. All of these streams will be archived there. and I also have other videos such as devlogs and stuff like that. So feel free to check that out as well. And of course, if you like my work here, I would greatly appreciate it if, of course, you can to support me on Patreon. You don't have to, of course, but any support is appreciated. It allows me to get things like this Mac here for me to test on, right? So that was actually paid for by supporter income, right? And I can get better equipment and stuff like that. So everything that I make on it, I'm putting back into the channel for now, right? But yeah, anyway, I want to thank you guys so much for your support. I really appreciate it. And yeah, I'll catch you guys next time. See you guys later. Let me actually, before I sign off, let me find somebody to raid. Unless you guys have a suggestion of somebody I should raid. Let me go. Let's see who is on right now. Let's see who I can raid. I think I'm probably going to wind up going with... yeah, let's go ahead and let's do a raid on Ferret Software. So for those of you who are not aware of what Ferret Software is, Ferret Software is actually owned by Pirate Software, who's a game developer, and he's also sort of on the side running a ferret rescue for ferrets that were used in medical testing and stuff like that. And he adopts them and gives them a good home. And the ad revenue of this channel, 100% of it goes to the care for the ferrets, which are not they're not very cheap to be able to maintain. They're pretty expensive, actually. But it's allowed him to take on a bunch of ferrets. I think he has 13 at the moment, and give them a good life and a good home. And so from time to time, you'll see them come out and play and run around and stuff, and it's really adorable and amazing. And so I'd like to support that, and so yeah, that's who we're going to raid. But anyways, thank you guys so much, and I will see you guys in the next stream.